How can you use ratios, rates, and unit rates to solve problems? Nathan and Dan were both hired as lifeguards for the summer. They received their paychecks for the first week. Who earns more per hour? We can develop a model to show how the quantities are related. The rate can be written in two ways. Which rate is more useful for this problem?
Select your answer.
First, model Nathan's pay. He worked a total of 5 hours. He earned $46.25. Now, model Dan's pay. Dan worked a total of 9 hours, and he earned $78.75. Now, find unit rates to determine how much each lifeguard earns per hour. Nathan earned $46.25 in 5 hours. How much money does he earn per hour? To find Nathan's unit rate, divide each term of the rate by the same number. We want the new denominator to be 1. By what number should you divide each term?
Select your answer.
Divide each term by 5. The second term is now 1 hour. The first term is 46 25/100 divided by 5, or 9 25/100. Nathan earns $9.25 per hour. Dan earned $78.75 in 9 hours. What is Dan's hourly rate? This time, divide each term of the rate by 9 to find the unit rate. Dan earns $8.75 per hour. So, comparing the two unit rates, Nathan earns more per hour than Dan.
Jennifer is a lifeguard at the same pool. She earns $137.25 for 15 hours of lifeguarding. How much does Jennifer earn per hour? What do you notice about the models used to find how much each lifeguard earns per hour? Brian agrees to watch his neighbor's dogs for 7 days. His neighbors provided a 128-ounce bag of dog food. Does Brian have enough food to feed the dogs all 7 days? Explain.
All right, so this is a multi-step problem. We first need to figure out the unit rate of each dog. So we'll work out Buster's unit rate first. And we can set up equivalent fractions like it was in the first example. So I'm going to set it up as a unit rate problem. So we know 20 5/10, that's ounces, and then 2 is days. And the reason we are putting days in the denominator is because that's what we need to get to 1, because it's asking us how much does the dog need in 7 days. So to figure this out, we need to make sure we have days as 1. So just like the first example, we know we tried to get days to 1. So you had to think, well, what did I do to 2 days to get to 1 day? Well, you probably would have said subtract 1, but we need to think of division. What did I divide 2 by to get to 1? Well, we know we had to divide that by 2. Whatever you do to the denominator, you need to maintain equivalency and do the same thing to the numerator. So we're going to divide this by 2 as well. Now you can do standalone division. So that would look like 20 5/10 divided by 2. I know 2 goes into 20 10 times. Minus 20, that leaves me with 0. Remember to add your decimal point, bring down your 5. Well, 2 goes into 5. 2 times, that's 4. I have 1 left over. Bring down a 0. 2 goes into 10. 5 times. So that means I'll put ounces. So Buster actually eats 10 25/100 ounces per day. That's how much Buster eats. Now we need to figure out how much Roxy eats in 1 day. So we'll do the same thing. We'll put 22 5/10 ounces. Now I put my units on the left so I won't run out of space. And then 3 days in the denominator. And we know we're trying to get the denominator to 1, so 1 day. And what did we divide this by? Well, we divided it by 3 to get to 1 day. Maintain equivalency. Do the same thing to the numerator. Divide by 3, and you could do standalone division. So it'll be 22 5/10 divided by 3. Well, I know 22 goes in, 3 goes into 22 7 times. That equals 21. I have 1 left over. Decimal point. And bring down your 5. 3 goes into 15 5 times. So that means Roxy actually eats 7.5 ounces per day. Now this is not the final answer. I can use distributive property. So if I take out 7, I know I need to add how much Buster eat per day and how much Roxy eat per day. So when I add how much the dogs eat together in 1 day, that gives me 17 7/75. So this 17 7/75 ounces is how much both dogs eat together, how much they eat together. So then, to figure out how much they eat in 7 days, you just multiply by 7, which is 124 2/25. Now, that's not the answer. So the answer is, does Brian have enough food to feed the dogs all 7 days? Well, we know Brian had 128 ounces for the 7 days. Well, we know 128 is larger than 124 2/25. And this is how much the dogs ate in 7 days. But this is how much Brian actually had to feed the dogs. So the answer is yes, Brian will have enough dog food to feed the dogs for 7 days. All right, step 1, use unit rates to find how much each dog eats in 7 days. So we did that. We know we had to get days to 1, that's our denominator. And this says amount Buster eats in 1 day. And then you multiply that by 7 days, amount Buster eats in 7 days. So we know that 71 7/500 ounces is how much Buster eats in 7 days. Then you would do the same thing for Roxy. Alright, so step 1, use unit rates to find how much each dog eats in 7 days. Step 2, find the total amount of dog food needed for 7 days. Then compare.
Suppose that each jump covers the same distance. How many jumps does it take each animal to cover the exact same distance?
So this question is asking, how many jumps does it take each animal to cover the exact same distance? First, I'm going to write out a chart. Alright, so here are my charts and I need to fill in the first boxes. So we're going to focus on the rabbit. We see here the rabbit jumped 1, 2, 3 times and went 8 meters. So that'll be for the first box. So 3 jumps and 8 meters. Now, the kangaroo rat, we know it jumped 1, 2, 3, 4, 5 jumps and went 12 meters. Now we need to figure out how many jumps does it take each animal to cover the exact same distance. So we're going to try to get the meters to the same number. Well, let's go ahead and double 12. So I'm going to multiply that by 2. Now this chart is just listing equivalent ratios. So I just doubled that. Now whatever I did to the meters, I have to do to the jump. So I'm going to multiply that by 2 as well. So then I know 5 times 2 is 10. Now let me do the same thing to the other side. Well, I'm trying to get to 24. So what do I need to do to 8 to get to 24? Well, 8 times 3 is 24. Now I'm going to do the same thing to the other side. Multiply that by 3. So 3 times 3 is 9. So to answer this question, how many jumps does it take each animal to cover the exact same distance? It will take the rabbit 9 jumps and the kangaroo rat 10 jumps to cover 24 meters. Now, there's several ways you can do this. This is one way. All right, so this is how the example was. Well, they multiplied for the kangaroo rat 12 times 2 and got 24, and the jumps by 2 and got 10. On the rabbit, we see they went in increments of 3. So 3, 6, 9, and then 8, 16, 24. The rabbit jumps 24 meters in 9 jumps. The kangaroo rat jumps 24 meters in 10 jumps.
A kitchen sink faucet streams half a gallon of water in 10 seconds. A bathroom sink faucet streams 7/500ths gallon of water in 18 seconds. Which faucet will fill a 3-gallon container faster?
All right, the first thing I did was wrote down my charts. So I have a chart for kitchens, and it has seconds and gallons, and then I have the bathroom with seconds and gallons. The first thing we have to do is fill in the first box. And we know what the first box is for kitchen because here it says kitchen sink faucet streams 5/10 gallons of water in 10 seconds. So that would be the first box. 10 for seconds and a half for gallons. Now for the bathroom, what we know, it says 7/500ths gallon of water in 18 seconds. So for seconds, it'll be 18, and gallon, it'll be 7/500ths. Well, you can go ahead and start figuring out numbers now. So let's just multiply this by 2. Well, we know 7/500 times 2 is 1 5/10. Now we need to maintain equivalency and do the same thing to the other side. Well, 18 times 2 is 36. All right, so remember, we're trying to get gallons to 3. So I'm going to continue focusing on bathroom. Well, what do I need to do to 1 1/2 to get it to 3? Well, I need to multiply that by 2 again, which will give me 3. And then I'm going to do the same thing to this side. Well, 36 times 2 is 72. So I know for the bathroom, it will take 72 seconds to fill up 3 gallons. Now I need to do the same thing for the kitchen. Well, I'm going to multiply this by 2. And I know half of 2 is 1. Then I'm going to multiply this by 2 as well to maintain equivalency. And I know to fill up 1 gallon, it'll take 20 seconds. Well, what do I need to do to 1 to get to 3? Well, I'm going to multiply that by 3. And I'm going to do the same thing to the other side. So 20 times 3 is 60. And 1 times 3 is 3. So for the kitchen to fill up 3 gallons, it will take 60 seconds. Which faucet will fill a 3-gallon container faster? Well, if we look at it, the kitchen takes 60 seconds and the bathroom takes 72 seconds. The kitchen will fill up the 3-gallon container faster than the bathroom.